Hi everyone, my name is Anna Gaudier, and today I'm going to be speaking to you about my Digital Futures postdoctoral project on designing rules for multi-robot systems. This project takes place at KTH, supervised by Yana Tumova and Yolanda Late. Robots are becoming a part of our everyday life. On the left, you see a picture of me with a robot in my local grocery store in the US about 5 years ago. And on right, we see the food delivery robots that are popping up around the world. This one, you can tell, is quite surprised to encounter a marching band in the streets and is unable to handle it. So as a robot designer, what kind of planning challenges do robots face as they move into the real world? Well, one, robots will start to encounter other autonomous robots that are owned and operated by different companies. And two, robots will encounter humans outside of easily controlled settings. These are difficult problems because it requires a robot to consider the intentions of the agents around them, whether those other agents are robots or humans. I argue that game theory and mechanism design are good models for these type of interactions. Game theory allows us to represent a system of robots and humans with their actions, preferences, and intentions, and then understand how all the agents will act and react in this system. Mechanism design, on the other hand, can help design rules for robot interaction under a game theoretic model. We can design rules that help us optimize for all sorts of interesting problems. Of course, we need to make sure our robots achieve the goals that they are assigned, but we also need to consider constraints like minimizing the risk of robot failure, ensuring safety, or engendering trust. In prior work, we've used mechanisms like auctions to design rules to divide up scarce resources among agents, even in scenarios with a lot of uncertainty. Scarce resources can include things like compute on a shared edge computer, Wi-Fi bandwidth, electricity, or even human assistance. In current work, we're keen to include mathematical and game theoretic models of humans to allow us to extend these type of rules to systems that include humans. This is a two-pronged problem. First, we have to design intelligent robots with strong guarantees based on some assumption about humans, but we also need to rigorously and experimentally evaluate the fidelity of our models and assumptions. We're keen to relax the rationality assumptions on humans in game theoretic modeling in order to maintain high fidelity to real-world interaction. But we're also keen to keep enough models of humans, or keep a strong enough model of humans to achieve strong guarantees on robot safety. Thank you so much for listening, and if you're interested in hearing more, please feel free to send me an email.